Next up we have an ellipse. An ellipse is a closed curve on a plane. In nanoCAD there are three drawing modes: bi-semi-axis, bi-axis, and semi-axis, and elliptical arc. Let's start with the bi-semi-axis mode. Pay attention to the command line or to the dynamic input for hints. We specify the center of the ellipse. Then set the value of the end point of the semi-axis as 500 and press enter. Then we need to specify the length of the other semi-axis. Let's set it to 1000. This is how the ellipse we just constructed will look. Accordingly, the geometry can be edited. But remember that the value of the major semi-axis cannot be less than the minor semi-axis. Next, we'll use the bi-axis and semi-axis mode. Now specify the first and second endpoints of the axis. Then we specify the length of the other semi-axis. Let's also set it to 500. Enter. And the ellipse bi-axis and semi-axis will look like this. In the same way we can see all the properties on the functional panel and edit them. Next on the list is the elliptical arc. This one is a bit more complex. You need to specify the end point of the arc or the center, then the second end point of the arc. Next, the length of the other semi-axis. And the starting angle. Let's go from 90 degrees, and then we can set the final angle. Let's make it 180. Enter. Then the elliptical arc will look like this. We can stretch it using the editing grips. Then the center can be moved just like with any other editing grips. Let's briefly discuss working with splines. We use them relatively less often compared to the main drawing modes. They're often used to construct horizontals, contours, and symbols. Let's use the spline with fit points and arbitrarily make a construction. We see a curve was created based on our fit points. To finish the command you can use the spacebar or enter. After selecting, the editing grips will be displayed, which are the fit points that we specified for constructing this spline. Using them we can change the position of the control vertex. We can add, remove, or stretch. We can also switch from fit points to the control vertices using the round editing grip. We can also use this plane based on the control vertices and similarly switch from it to a spline based on fit points. And, accordingly, the same option apply: add, stretch, remove. Also, interestingly, we can convert a polyline into a spline. For example, we have such a broken polyline. Next, we select one of the splines and choose the object option. Select an object to convert into a spline. Pointing to our polyline, press enter. And just like that, the polyline is easily transformed into a spline. That's all for this tool. Now we will proceed to study the second group of primitives. These are construction line, ray, point, revision cloud, donut, and helix. This tool is used less often than the main drawing modes, and now we'll discuss each of them in more detail. Construction line and ray are auxiliary lines. And they look like this. Remember that the construction line is an infinite line, which has neither a beginning nor an end. In the following options, offered by the command, we can draw a line horizontally or vertically. We can set an angle bisector and offset. Let's use a horizontal line construction. If necessary, we can simply turn on ortho and we can build strictly horizontally or vertically. But the difference here is that we can start drawing further, meaning there won't be an intersection from one point. Vertically, it's already clear what it is. Let's cancel the command. Let's use the construction line again and choose an angle. You can use the spacebar to repeat the last command. First angle or baseline. Let's set the angle of the line to 45 degrees. Enter. Next, we need to specify the construction point. Let's place it at the intersection of the line. In the same way, we can continue the construction at the set angle. End the command. Choose the construction line again. A bisector divides the angle in half. Let's specify the nearest angle vertex. Point on the first ray of the angle. And point on the second ray of the angle. In this way, we can construct a bisector just by specifying the nearest point and the angle points. The last thing we can do with the construction line is an offset. Offset basically works just like the move command, but it's in the editing group. Let's set an offset value of 1000. Enter, and choose a linear object. After specifying the line, you need to specify the side for the offset. Next up, we have the ray. A ray has a beginning but no end. We can arbitrarily specify the first point, and the ray will look like this. The working principle is almost the same. Specifying the base point through a point, so we will continue later the construction as in the first, and actually, that's it. This is how auxiliary lines work. Now let's move on to the next tool, which is point. This command allows you to create what are called point objects, which can appear as a regular point or a special symbol. Now, we've created 2 points. Their appearance looks usual. To change the appearance from a point, we will use the mode variable. Now we need to set a value for this point. I'll use the value that I remember, which is 98. I'll suggest where to find all other values later. Enter. Now, I'll use the point again. And the point will have the following display appearance. The program's help can be accessed online. Point. Select the point. Here you can also read all the basic information about this tool, specifically its variable values to change the point's appearance. Currently, we have this option presented. It can be changed using the system variable that we entered earlier. And that is. The next drawing mode is revision cloud. The cloud consists of arc segments, the length of which we can adjust. More often than not, the cloud is used to highlight explanatory notes or to make markings on the drawing. The cloud offers many parameters that you can use, some of which we will apply. Let's leave the arc length unchanged and do the first construction. Styles can be normal or calligraphic. So here, we already have the calligraphic style represented. Let's use the normal style for subsequent construction. And here, we see that it has a normal style without transition. We can also construct a cloud with the opposite arc direction. And we can also transform a circle into a cloud. Select the object setting and then select the circle. We can change the direction to the opposite. Let's select No. And this is how a circle transformed into a cloud will look. The same goes for splines, standard arcs, and so on. Next there is a donut command, which consists of 2 arc polylines, which at the end are connected and form a circular shape. On the drawing without inputting data, let's specify the inside diameter and the outside diameter. The appearance of the donut will look as follows. Without ending the command, we can subsequently duplicate the resulting donut, and only after finishing the command the donut construction stops. Using editing grips, we can change the diameter. To get a fully painted contour, you must set the value of the inside diameter as 0. Let's try it. Inside diameter 0. Enter. Outside diameter. In this case you get a fully painted ring. We can also see that these are indeed two polylines that are connected at their ends. And we can change the appearance of the ring according to what we need. Let's conclude our study of the second group of primitives with the helix. Let's move on to the additional tools and use the helix command. The first thing required from us is to specify the central base point. Next, we define the radius or diameter, and then we specify the top base radius. Next, indicate the height of the spirals, if required. Let's try specifying 2000. Enter. And to check if our helix indeed has a height, we'll switch to the front view. Here is the helix we've obtained. After selecting it, we can use the Properties panel. We can change the properties of the spiral, as a result of which its appearance will change. Helixes are useful for creating objects like springs, threads, and certain curved staircases. And we move on to the third group of primitives, which includes wipeout, divide, measure, hatch, gradient. Now, we move to wipeout, and its main function is to cover what is beneath it. In other words, as you have already seen, the command creates masking objects in the form of polygons that have a background color, which can be used to cover drawing mode's objects. The masking object should always lie above the masked ones. Using the wipeout frame sub-options, it can be made invisible. If we disable it, the frame of the masking disappears. It can also be enabled again. We can also convert a closed polyline into masking. Let's see an example. Let's draw a rectangle again. Apply wipeout to the rectangle. Polyline. Erase the polyline, let's choose No. Thus, the frame of our rectangle's polyline became masking. You can view using the contextual properties, and they perform the same role as wipeout. And if necessary, you can simply delete. Using the editing grips, you can change the frame, you can stretch as needed. You can also create an layout space to hide objects located in the model space. This is how wipeout works. Next up are measurement and divide elements. The divide command will distribute on an object or its perimeter points or blocks at equal distances. Let's see an example on a line segment. We'll use the divide command. For this, we need to select the object to be divided and specify the number of segments. Let's specify 6 segments. Enter. Since last time we changed the appearance of the point display, it will look like this. The next command, which is somewhat similar to the divide command, is measure objects. The only difference is that we need to specify the distance to which we want to distribute points on the object. To do this, in the same way, we will draw a random line, then we'll choose the command measure objects. Select the object and specify the segment length, let's say 2000. Enter. In this way, our line is divided into equal segments based on the specified distance. The next and last 2 sections, 2 commands, are hatching and gradient. The next dialog box opens a set of hatching parameters. Using the double arrow, you can expand additional drawing modes for work, and the first thing we see is type and pattern. There are 3 types: predefined, user-defined, and custom. Next, we see a pattern, which can be selected from a drop-down list. You can also open an additional hatching pattern window. Next, you can set the angle and scale. Specify the hatch origin, add pick points that you want to hatch. For associative hatching parameters, the checkbox should undoubtedly be checked, then island detection. Here in preview, it's clear how each type of islands will operate. Boundary retention, boundary sets, gap tolerance, and inherit properties. We won't go into detail now, we'll just highlight some key aspects. To hatch a particular object, you need to specify the type of pattern, angle, scale, what type of island you want to use, and select the pick points. For example, let's hatch a circle. Enter. You can preview it beforehand. To finish the action, press Enter. This way, the hedge will fit into the selected area. And later, you can continue to edit it. Also, you can stretch the hatch, choose the base point, set the hatch angle, and scale. In the Properties toolbar, you can change some parameters. Also, to open the Hatch Parameters dialog box, double-click on the hatch with the left mouse button. Let's move to Gradient Fill. The only things that change in this dialog are color, type of gradient fill, and orientation. Let's immediately add the object's pick points, highlight our circle. Enter. Confirm. With the current settings, the gradient fill will be displayed as follows. Now, we won't jump ahead because our next lesson is on hatching, in which we will discuss the hatch parameter settings in more detail, and we will also try to create our custom hatches.